So the next part of the area unit is focusing on the area of trapezoids, kites, and rhombi. So the first thing we're going to do is look at the formula for all three of these figures, and then create an illustration that shows every part of the formula within the three figures. So the first one is the illustration of the trapezoid area formula. The trapezoid area formula is area equals 1/2 times the height times the sum of the bases. Remember that the bases of a trapezoid are going to be the sides that are parallel with one another. So in this illustration we can say that this is base 1, that this here is base 2, and just like my triangles and my parallelograms, the height is going to be perpendicular with these bases. Now, just like the parallelogram, the height can be drawn in multiple places as long as it's connecting the bases and it's perpendicular with those bases. So all these heights, you can see they're perpendicular with the bases and they're all parallel with one another. So again, the formula is 1/2 times the height times the sum of the bases of the trapezoid. Now let's look at the area formula for a kite. For a kite, the formula is, put it over here to the side, area equals 1/2 times diagonal 1 times diagonal 2. Now what these D's or these diagonals actually stand for are these lines connecting the vertices within the kite. So this is a diagonal line, this is a diagonal line. Whatever you want to label as diagonal 1, diagonal 2, it doesn't matter. Okay, since you are multiplying them together, it does not matter which one is D1 and which one is D2. So just to label these here, we'll draw these little braces and say that this is your diagonal 1, that full length of that line, and this is your D2 or your diagonal 2. So the formula for area of a kite is 1/2 times diagonal 1 times diagonal 2. Now let's look at the illustration of the rhombus. Now the rhombus and the kite are going to have the exact same formula. Okay, it's still going to be area equals 1/2 times diagonal 1 times diagonal 2. Because we're really talking about pretty similar figures here in terms of their looks. The difference is we know that in a rhombus, that my rhombus is going to be congruent, have all sides congruent. Okay, that's the difference between the rhombus and the kite. And also the opposite angles of this rhombus are going to be congruent as well when that does not actually occur in a kite. It only occurs with one pair and not with two. So I'm going to go ahead in here and create these diagonal lines. So diagonal line number 1, diagonal line number 2. You can see, remember in a rhombus, this perpendicular, these perpendicular lines are created here in the center. Alright, but this would be my diagonal 1 and my diagonal 2. Now, if we go back real quick to the kite with my diagonal 1 and diagonal 2, remember also in a kite that this shorter diagonal line is bisected by the longer diagonal line. So the shorter one is bisected by the longer one and not vice versa. So if this whole diagonal line is 10, then I have 5 and 5. So that might come into handy when trying to figure out my, my different diagonal lengths when trying to determine area. In a rhombus, the longer diagonal bisects the shorter, and the shorter bisects the longer. So I could say that this is 5, and this is 5, and maybe this is 2, and this is 2. So what I have here is I have 4 right triangles that all have the same exact dimensions. They're all 2 by 5. So I could say 2 times 5 divided by 2, and multiply that by 4 to get the area of my full figure. Or I can just go ahead and utilize this area equals diagonal 1 times diagonal 2 formula for my rhombus. Alright, let's jump right into my example problems. Example problem number 1. What is the area of trapezoid PRQS? So what is the area of trapezoid PRQS? So things I know that I need for my trapezoid. I know I need a height. I know I need a base 1 and a base 2 length. So here I have a base 1 length of 7 and a base 2 of 5. So I can say 7 and 5. Those are interchangeable. And then I have this 60-degree angle here in the bottom, but I don't have my height. So what I'm going to do here is I'm going to go ahead and create my height. And I know my height needs to be perpendicular, so I'm going to go ahead and create two little triangles here. So I need to figure out a way to come up with this length from S all the way down to this base. So I'm going to re-illustrate this triangle over here of what I'm trying to find. Remember, it's a right triangle because when the height intersected with the base, it was perpendicular. And I know that I have a 60-degree angle here. I'm trying to find my height. Now, if I'm going to use trig, or if I'm going to use special right triangles, I need to have at least one side length given. Now, in my original figure, I have this trapezoid that has one base of 5 and one base of 7, and when I created this height, it created a rectangle. Now, what I know about rectangles is that opposite sides are congruent. So if this is 5, then this is 5. We'll call this little point here T. So if S to R is 5, T to Q is 5. If this whole side of PQ is 7, what does that leave me with for PT? That leaves me with a side length of 2, right? So I can then translate that over to my new illustration and allow for this to help me find what I'm looking for my H value. Now, I'm going to use trig. You can use special right triangles if you want to, your 30, 60, 90. But using trig here, I know that I have no value in the hypotenuse that I'm trying to find or that I'm given. So automatically I should say that I'm going to be using my tangent function. So the tangent of 60. Remember that the tangent function is always opposite over adjacent. So the opposite from 60 is h and the adjacent is 2. So h over 2. So now all I'm going to do is I'm going to calculate the value of h. So I'm going to be multiplying 2 by the tangent of 60 in order to get my h value. So 2 times the tangent of 60. My h value is going to be 3.46. Now I'm going to go ahead and put that over here in the information that I needed. So now I have all the information I need in order to solve for the area of my trapezoid. I haven't given myself much room over here, so I'm going to try to squeeze it in over here on the right. Okay, but I know that area is equal to 1/2 times my height, which we just said was 3.46. Carry this down, times the sum of my bases. So 7 plus 5, which we know is 12, but we're going to write it down anyways just so we can practice using that formula. So area is equal to 12 times 3.46, and then I'm going to cut that value in half by either dividing it by 2 or multiplying it by 0.5. So my final answer is going to be 20.76. In this case, we have meters squared. I really tried to fit that in over here. 20.76 meters squared. So we utilized trig a little bit. We were given the bases. We had to use trig because we had to figure out what that height was. Once we found the height, we implemented that into our trapezoid formula. All right, let's look at example problem number 2. On example problem number 2, we're trying to find the area of a kite on a coordinate plane. So we need to figure out what the diagonal lengths are, because that is what is included in my kite formula. So I'm going to go ahead and draw my diagonals here. There are my diagonals of my kite. So I need to know what these lengths are in order to figure out my area, because those lengths are going to determine my diagonals. Those diagonals are going to determine my area. So I'm going to have to use, well, I can use one of a couple things. Here you can see this right triangle that's formed that has a side length of 3 and 3. And then I would have to use 3 squared plus 3 squared equals c squared to figure out that length. You can do that if you'd like to. Actually, let's go ahead and say 3 squared plus 3 squared is equal to c squared. So that's figuring out what one diagonal is. Now for the other one, if you want to, you can create the right triangle, but I'm going to go ahead and use our distance formula so we can practice that method. So distance formula requires me to have 2 coordinates. Okay, I have a coordinate here at 0, 0, and I have a coordinate here at 5, 5. So I have a coordinate at 0, 0, and a coordinate at 5, 5. So remember, my distance formula is going to be my change in x squared. So from 0 to 5, it's 5 units. So I'm going to say 5 squared. Plus my change in y squared, same change as before, as with my x's, is equal to my distance squared. A lot like the Pythagorean theorem that we had here. And if you were to create a right triangle with TR being your hypotenuse, you would get side lengths of 5 and 5. So over here I have 9 plus 9 equals c squared. 18 equals c squared. So my c value is going to be the square root of 18. We'll round to the nearest hundredth, which is going to be 4.24. Okay, and we're going to go ahead and change this c to diagonal 1, because that gives me that length from Q to S. And then over here we'll do the same thing, except we have 25 and 25 instead of 9 and 9. So 50 equals d squared. Take the square root of both sides. So 7.07 becomes my diagonal 2. So now I have the information that I need. I needed the two diagonal lengths, diagonal 1, diagonal 2. So my area is 1/2 times my diagonal 1, which is 4.24, times my diagonal 2, which is 7.07. Scoot that over for you. So 4.24 times 7.07 divided by 2, or times 1/2, whatever you want to call it, gives me 14.988, so we'll say 14.99 units squared for the area of my kite. Alright, last one, example 3, finding the area of my rhombus. I still need diagonal 1 and diagonal 2 just like before. But remember back here at the top of the notes, we discussed how a rhombus, the diagonals bisect one another. So if this whole thing was 4, it becomes 2 and 2, 10 becomes 5 and 5. So if we're looking at my problem down here, I know that if this piece here is 8, then this will also be 8. So I know that my diagonal 1 length is going to be 16 inches. But what I do not know is what diagonal 2 is going to be. So I'm going to use this 30-degree angle and this 8 to figure out what this length is of this rhombus, and then double it to get my full diagonal 2. So on the right-hand side, I'm going to re-illustrate my triangle. Beautiful drawing. So again, you can use special right triangles or you can use trig. Okay, I'm going to use trig because I like trig. So I'm going to go ahead and use my tangent function again because I have nothing in my hypotenuse, so tangent of 30. Remember, it's opposite over adjacent, so I have my value that I'm trying to find, we'll call x, x over 8. So that means I'm going to be doing 8 times tangent of 30 is equal to x. So 8 times tangent of 30 is going to give me 4.62, which now is 1/2 of that side of the of that diagonal length of that rhombus. So in order to get D2, that full length, I want to take that 4.62 and double it. Okay, so I'm going to double that 4.62 in order to get the length of D2. So 4.62 gets doubled, and I get 9.24 as that short length. So now I have enough information to put that into my area formula. Area equals 16 times 9.24 times 1/2. So that gives me 73.92 inches squared. So there's my final area. So 2 different formulas really that you're learning. Trapezoid, 1/2 times height times the sum of the bases. Kites and rhombuses, both at Rhombi, both have the same of diagonal 1 times diagonal 2 times 1/2. So we'll be utilizing those to do your work on Wednesday and Thursday of the week of, what is this? We're at April 21st, so this will be for April 23rd and April 24th. Have a great rest of your week.